So hi, everyone. I'm Gil. Thanks for having me. Hope you can all hear me all right.
We do.
Great. So I'm here to talk about conch. I'll drop a link to these slides in the chat, although I'll tell you truthfully, there's not a whole lot there. Most of this is just going to be me typing very quickly. Conch, oh, and thanks for the organizers for inviting me. Forgot to say that. Conch is a Python-powered bashwords-leaning cross-platform shell. What does that mean? We'll sort of get there, I think. My name is Gil Forsyth. I work at a place. I'm G Forsyth on GitHub, and I've been contributing to and maintaining conch since about 2015. There are about like 100 contributors who are sort of regularly active. It's about 10,000 commits over 6 years. It was started by Anthony Stopatz. Some of these other people here have contributed many, many things over the years. The current maintainers are myself and Daniel. We have truly no idea how many users we have. It's a really hard thing to measure. We get about 12 to 13,000 downloads a month from PyPI, but also there's Condaforge. We don't know how many of those polls are just CI things running, although it's weird to download a new shell in CI. Also, we're packaged with a bunch of Linux distros. We're available on Brew, and people tend not to like frequently reinstall their shell. So it's hard to get a sense of the actual user base without putting horrible tracking stuff in that we don't agree with. So we just sort of stumble forward blindly. That's kind of the moral of the story here. This would work better in a room, but I'm curious if people want to throw answers in the chat. I'm just like to see sort of who here uses Bash or Z shell or something else, or has no idea what I'm talking about. Okay, got a Bash, got a Z shell, got a Bash, got a no idea, Bash, Bash, Z shell, Z shell. Okay, cool. Nice, a nice mix here. So for the no idea crowd, and that's fine. So the shell is, that thing you get when you open a terminal. And for a long time, the default on Linux and certainly on OS X was Bash. OS X switched over to Z shell. On Windows, there's things like PowerShell and some other tools. But it's the thing that you can interact with at the terminal, and it is itself a language, right? You can write code in it. You can interact with your file system. You can move around. So conch is one of those, and I'll sort of go through some of what it can do in a second. In terms of who might be a good, might enjoy using conch, these are things that probably are not a great fit. If you really love writing Bash, and no shame if you do, but you probably aren't going to switch. If you've got like 10,000 lines of like handcrafted RC files that represent 20 years of learned experience, you probably want to stay where you are. If you require strict POSIX compatibility, we don't do that. So maybe don't like run your incredibly important prod stuff on this. If you hate Python, this is it's a bad meetup to be at, frankly, and also the shell is not going to go super well. Alternatively, if you kind of avoid or shy away from writing code in Bash or Z shell, if you have those 10,000 lines of RC files, but like you got them from Stack Overflow and you don't really know how they work or how to edit them, if you really like Python, if you ever wanted to write a custom tab completer and tried it and found out it was really hard, then maybe this is sort of a good place for you. But we'll see. This is a very brief history. It's actually only one slide of history. I just like that this is what we started with. This sort of sums up a lot of things. It's much better now. What just happened on my screen? Interesting. Okay, so what actually is it though? And I'm glad you asked, or I asked myself, because I stopped making slides at this point. So I'm gonna pop over here to a shell prompt. Is this big enough for everybody to see? Can you read this?
You're good.
Awesome. All right. So conch is a shell. So what that means is that, for instance, you can run shell commands like ls, you can run ls-l, just see some files in here. You can look at environment variables, your path. You can pipe things from one command to another, right? So you may want to look for something called ASCII in here, and there is a file that has ASCII in the name. So all of that are kind of common shelly things. You can capture the output of commands. This is where things will start to diverge from expectations. That doesn't really do what people expect it to do. I have to do something else, which I'll explain more in a little bit. But the point is you can capture the output of a command and then kind of echo it back out to the screen. So that's the shell stuff. Conch is also Python. And what that means is that first, you can do anything you could do at a Python REPL. So you can do math, for one thing. You can import things and run them, right? Do like a, request.get at Google. You can import NumPy, and you could maybe create a little, random array there, and you could multiply it against itself. That all works. And you can write for loops, which I think was the original title of this talk, which is true, because I don't know how to do this in Bash because I forget every time. And you could write a comment, and you could put in a conditional maybe, and then maybe you want to print out what that thing is. And that works because it's Python. It's a Python REPL. One point I want to note here, I'm using something called VI mode with this, and this is a fully multi-line prompt. So what that means is if I go up in history, I can actually hit escape, and I can navigate around this history thing here, and I can move stuff around. Like I can decide this conditional doesn't make sense, so I can just delete it. I can move this over. I can decide I want the comment to be below, and then I can run it. So you can have something akin to a VI or Emacs style editor right in your terminal. You can also do the usual kind of Control-E, open it up in your editor of choice, and then save out and run it. But, so that's just a fun little bit of editability. The other thing that Conch is it's both of the things I said it was. It's a shell and it's also Python. So what I mean by that is that you can do things that technically don't make any sense, right? Like, so I have written a for loop in Python, but the body of my for loop is an echo command, which is, just the usual echo in my operating system. This usually leads to the question of, well, cool, how do I want to echo the I? And that doesn't really work the way you might want it to, because echo I is a valid command to run. So we have a way to basically pass from this Python context the loop is in to the subprocess context that this is in, which is this @ symbol. And this is saying, I want you to grab the I from my Python loop, and I want you to feed it in to this non-Python command I'm running, so you can mix and match your friends. And then you get sort of the combined output of that. And there's a lot that's happening behind the scenes here, which I'll touch on if we have time. But a lot of the times it just works. And the other times you just have to add sort of a few little characters to make it a little clearer. For the computer scientists in the room, this is context-aware parsing, and people think it's gross, and it is, but it works. We have environment variables the way you do in Bash or Z shell. We don't do export. You just define them as you would a Python variable. And so you can then echo that, and you get your value back. You can also just type the value of the environment variable, and you get it back. So because it's more like a Python environment. You can also do environment lookups. So if you wrap a dollar in a curly brace, this is something Bash does too. You can feed it a name, and you get the result of that environment variable. But this is actually a little bit different. What you put in here is actually any arbitrary Python expression, and whatever it evaluates to will get looked up the environment and will return it if it exists. And so, I mean, like very many different kinds of expressions will work for this. I can use an F string inside of here if I want to be especially ridiculous, which I often do. I can, rot 13 something in here and get my home directory. So there's sort of a lot of stuff you can do here. And these environment variables are typed. And what I mean by that is that they have a type on our end, and then we convert them on the fly to pay nicely with things that already exist. So if I echo my path, you can see that it is a a list of colon delimited directories, which is what the path usually looks like in a POSIX environment. But it's actually not that. The path is a list of strings. It's a list of directories, actually. So what that means is a couple of things. One, this is, give me some space here. This is a Python object. And what that means is that there are Python methods on it, and it's a list. So I could actually, if I were so inclined, reverse it. And now my path is in opposite order. This is a bad idea, but you can do it. I'm going to put it back. It also means if you've ever been in the position of having like something in the middle of your path you wanted to get out and you end up doing some horrible copy paste to do it, you can actually just choose to pop individual variables off of your path. And now you've mutated it and you can do whatever you need to do with it. I actually don't want to do that, so I'm just going to stick it back in there so things keep working. So what is sort of the thing to remember here is that even when something like this behaves like it's not Python, it is. And that means that everything is a Python object and conch itself is Python. So you always have sort of the superpowers that come with Python available to you. If I return back to this initial thing I was showing you about capturing the output of LS, we notice that this doesn't really work and you have to do this @ symbol. But actually you don't need to do any of that because it's Python. So you could print it because that definitely works. You could also just type the name of the variable and get the raw string that was captured when you ran the command ls. So ls, if you capture that, has a bunch of new lines in it. So the actual output looks like this. And that is a string. And when I say it's a string, I mean it's a Python string. You can check the type of it. You get a string back. And what this also means then is that you can use string methods. So if I hit cap and I dot and I hit my tab, these will look familiar maybe to some people. Like these are all the sort of the usual Python string methods that are available. It also means that, for instance, I can do things like list comprehensions based on the value of cap and say like, well, if RE is in the name there, then I want to, just grab those files. This would actually be sort of, equivalent to running something like this and grepping for RE instead. So it's sort of up to you. Do you want to use Python? Do you want to use sort of the pipes and the usual built-ins you're used to? You've got the option to do both. We're sort of giving you a lot of ways to do things. So whatever you're comfortable with is sort of what you can choose to use. Seeing some questions. Is code wrapped on encryption secure logic? I'll have to follow up with that one later because I don't quite understand it. And yeah, the history files. I will touch on this more later, but Conch has very robust history. And actually what we have is a individual history file per session. So the history for this session is in this JSON file. There's also a SQLite backend. But when you go like up in your history, it's actually pulling from all your combined history files. But we give you a way to kind of look at a single set of commands that you've run. It does give you some interesting options. I will come to those, I promise. The other sort of capture that we offer is something called a command pipeline. And so that is a different thing that is definitely not in Bash, which is if you use a bang and parentheses here, that also captures. But the output of that is something a little bit different. It's what we call a command pipeline. And if we just look at it, you can see that there's a bunch of information. Like there was some standard in, some standard out, some standard error return code. And you can, kind of look at all these things by looking at the attributes, including, for instance, the output. So you can still get the output of the command you've captured. One of the other cool things about these objects is that they are themselves truthy. And what I mean by that is that if I were to put this in a like a conditional statement, then this won't flag because there actually is nothing in this directory that has a capital ICO in it. But if I were to instead add the, what is it? The, ignore case flag to grep, then that will return. So you can start to chain commands on the basis of the output of commands, and which gives you kind of a really nice control flow around, you know, is there a file here? Did I find these things? There's a lot you can do with it. I mean, some of them are silly, but some of them are pretty helpful. See a question. I assume older shell scripts can be run natively in conch just like it would in bash. Is it compatible? Yes and no. You can, conch is not strictly speaking compatible with bash in its entirety. You can source bash RC files. Not everything will work. You can also source Z shell files. The things that tend not to work are that the built-ins and the individual shells are different. So things can get a little bit wonky, but we try to tell you that. We'll tell you that we wrote some of your aliases or that we couldn't import them. So if you're trying to move RC files over, you can do that. If you want to run bash scripts natively, there's some things that are probably not going to work super great. Okay, aliases in conch are a dictionary. So you can create them by simply, you know, you create this dictionary called aliases. It's always there. You give it a key, you give it a value, and then if you look up which grep, you'll get that alias. Similarly, if I run grep here, I'm actually getting ag. And you can also create multi-line aliases, and that will do the favor of kind of selecting it, and then you can, and that'll still work, right? Ag is in a, ACK, which ag will still show, oh, that's the command, that's why. Yeah, which grep will show you what the output of that is. The other thing you can do, and there's a bunch of different ways to do this for much more complicated examples, but you can also assign a function to an alias. And if you do that, which somebody I think spotted in my history briefly, I can create an alias called banana. And the function I'm assigning into it is a lambda that returns the string, my spoon is too big. So now I can run that like a built-in shell command, and my spoon in fact is too big. So you can write functions, but instead of having to necessarily pass function calls, you get just sort of this more kind of integrated experience. This also then opens up piping into other things that aren't necessarily Pythonic. Yeah, there are, so there's some weirdness that happens here, coming back to this, which is that one of these things does what we want it to and one of them doesn't exactly. And so what's actually happening is that we parse every line twice. And if it's Python, we treat it as Python. And if it's not Python, we attempt to figure out what sort of subprocess command it is, and we run that. Sometimes that leads to not what you want. In this case, since echo I is something you can do, because you're just, you know, you're blatting out some characters, this is valid, so it gets run as a subprocess. So in those cases, we have to do the sort of extra bit of work to tell conch specifically, you know, use the Python value here. This also, though, leads to the first rule of conch and also some of the weird stuff that can happen if you're not aware of it. This will look worse than it is. The first rule of Python, conch, is that Python always wins. So if the subprocess is clashing with Python, Python wins. What I mean by that is that this command is you know, ls-l, and you know, lists your files and shows you the information about them. But if ls were a variable named 2, and that was the value of 2, and l were a variable that had the value of 1, then is this ls-l or is this ls minus l? And the answer is it's ls minus l, because Python always wins. Having said that, if you like delete one of those variables, so ls is now 2 and l is undefined, then ls-l will do the right thing because not everything in there is Pythonic. It'll run it as a subprocess. I have broken my ls command, but if I delete the variable that's assigned to 2, then it comes back. That freaks people out, and I don't blame you, but it honestly doesn't come up that much. The biggest collisions are well, on Windows, dir, which is definitely something Pythonic and definitely means something on Windows. So we recommend aliases for that. That's the main one that comes up. The other sort of big difference between most POSIX shells and conch is that we don't use backslashes for escaping things. We use quotes because we just don't like typing a bunch of backslashes, and it feels more natural. So if I want to make a folder that has spaces in the name, I just put quotes around it. And then if I want to look, you'll see that that folder shows up here with quotes. If I were to try to CD to that folder, I can tab and it will automatically wrap it in quotes because it knows it's going to need it. And now I'm in there, and that works just fine. But you can't, for instance, do this. That would be sort of the bashy way to get in there, and it's just going to freak things out. The third rule of conch is just silly, which is that we use X's almost everywhere because we really got into it. So if you want to look at your configuration, it's config. There's a plugin system called contrib. If you find yourself like thinking there should be a command for this and you can't figure out why it's not working, try starting it with an X. We try not to be too annoying, but sometimes we can't help ourselves. That's sort of a whirlwind tour of basic functionality. I have a few other kind of things that I think are cool that I wanted to show people. And then after that, I'm happy to take questions and try to defend these decisions. One thing that I really like is that this environment lookup thing is that we have a little shortcut, which is you pass an ellipsis to it. That gives you your entire environment. Like every environment variable you have is contained in there. It's a dictionary. So one of the really cool things you can do with this is that we added a swap method. I'm going to get to that one in a second. I think my terminal history is sort of giving away the game here, but what that means, though, and what this does, it's a context manager. And what that means is that inside of this context manager, I can run a command with it where I run this command in a mutated environment. So what I'm doing here is I'm saying, in place of my existing path, only use the everything except the first entry in my path. I'm basically saying skip the first thing in my path for the purposes of all the code in this block. And so if I run that, you'll see that I get the system Python, where if I run without it, it's actually not my default Python. But so you can mutate your environment temporarily, and then it will get restored once you're out of that block. This is something, I actually do use this because the way that system Pythoned, and oh, Jason, that is a great idea. It doesn't, and I'm totally adding it like later today. Jason just suggested that commands should show you a list of all available commands. I'm very sorry to say it does not, but you're definitely on track. One of the ways that I actually do use this at work, and I think is very useful, is that for a lot of command line tools, you need to insert your password into an environment variable so you don't type it out into your history. But even doing that usually means like typing it out into your history, like equals my great 00, something like that, which is not a great idea, especially if someone's over your shoulder. But what you can do with this instead is you can actually create new environment variables. And because this is Python, there's nothing that says that the value of this key can't be a function. So I'm going to do the thing you wouldn't normally do with this, which is then to echo the value of that. But I'll then get prompted by the get path built-in in Python to enter my password, which is, of course, Hunter2. But user path actually doesn't exist after that, right? This environment variable was only existent for this brief moment up here, and then it got deleted. So it didn't get put into history. It effectively is gone. So if you needed to run something and kind of securely enter some credentials, you can do this, and they will never show up in your history, and they won't even show up on your screen for someone to see. That's that. P-strings. We added some stuff to Python because this entire thing is actually a full Python interpreter written in Python. So that means that we can change things or add new features. So one of the things that we added was the notion of a p string. So if you're familiar with like f strings, which is a string literal, this is the path string literal. And what it does is it gives you a pathlib path based on the contents of the string that you gave it. This is super useful, or is a lot more useful probably in a shell prompt than it is in like regular Python, which is probably why it's not there. But you can interact then with that pathlib path and do all the things that pathlib lets you do, which is a lot of stuff. We also then went ahead and added PF strings just because it seemed like the right thing to do. So you can have a P string that's also an F string, and then you can use brackets in here to inject the value of a variable into it. And now you have the ability to programmatically construct paths based on the value of either Python or environment variables. I should have tested this first, but since I said it, we'll try it. I think I can just put home in there. Oh yeah, and that works. And then the last thing that doesn't really fit anywhere in a talk like this is the prompt. So if you've ever had to do something like export ps1 equals, I don't remember what any of these things mean because you wanted your prompt to show you some information, we actually have this string, and then these kind of curly braced in values are the values of a separate dictionary. So you can add stuff to your prompt and you can write it in Python. So if I wanted, let's just say, to have a random number at the end of my prompt all the time, because I really like random numbers, then I could add a prompt field called rand that is a lambda that returns a random integer between 0 and 50. And then I would just add that to my prompt string, and it will dynamically update. And now every time I run, I'm going to get a random integer. That will probably get really annoying really quickly, so I'm going to take it out. Okay, I have one more thing to show you, which is sort of how I write code in xonsh. And so I'll do that quickly, and then I'm happy to take questions from people. Or you can interrupt me too, that works. I have a utility that I wrote that I use to jump around, and I'll just quickly line this up. So here's my home directory. I lose track. I have a lot of GitHub repos cloned down. So what I did is I decided I was going to sort of recreate the GitHub org repo structure on my file system. So I have a folder called github.com. In that are a bunch of organizations, and then inside of that are the repo names. And so what I want to do is I want to stop like accidentally recloning the same repo in different places. And I want to just be able to jump to those repos really quickly and have tab completion to do that. So I'll just show you quickly what that looks like. If I use the command G, I can tab complete, and it's a little bit of a bug there, and I can go to any of the repos I have locally, and that will jump me over to my .files repository over here. But I'll go back now to my Meetup talk. But I could also start a new variable, because maybe there's a package that I want to clone that I don't have. So I'll get this wrong, but I don't have fast API. Is it Tiangolo? Is that the right username here? Anyone? We'll find out.
Yeah, that's right.
Oh, yeah, sweet. So you see, it knows I don't have that, so it cloned it, and then it dropped me into that directory. If I try to do that again, let me go to my home directory. If I try to do that again, if I can type, it'll just jump me back there because it knows it's there. And then you're there, right? So I'll just walk you through really quickly how that works, because I could not begin to tell you how I would write that in Bash because I'm just not that good at Bash. But I know how to write it in Python, which is what I did. So, example, great name, Gil. This is the code for that. And I'll walk through it pretty quickly because I don't want to, bore you all to death. But I've got one thing from the const library to change the working directory. I've got a moderately horrible regular expression to parse out GitHub URLs. And then I have a function here, which is called clone or cd. So I grab the URL that's getting passed to it. I look for any matches, which would be, github.com and then an org and then a repo. And then I'm using the here, these are sort of the overloaded pathlib paths. So I'm building the path, right? The base is my home directory plus github.com. And org is base/org and repo is org/repo. And I'm just running a bunch of checks. If the repo exists, just put me in there. If the org exists, put me in there and then clone the repo I just asked for into that directory and then move to it. If the base exists, which would be github.com, then move in there and then make a directory of the org name and then change into it and then clone the URL and then change into that. And if it already exists, then just move there directly. So that's the entire bit of code that does all of that jumping around. It's just checking that directories exist. If they don't exist, it clones them. All of this 20 lines of code, this does all the tab completion for everything I just showed you. So I have a function called list repos. I have a path string path. I look in github.com on my file system. I look for every glob that fits, a two directory structure, and I return it as a list. And then I just have a little bit of boilerplate here, which basically says, if the argument you get is G, then return this list of possible matches. And then I am giving alias, I'm creating an alias called G, which I've set to the name of this function. And then I'm adding a completer, which is this function here. And just that stuff there is why when I hit G, you can see, hopefully there's nothing too compromising in here, every single GitHub repo on my laptop, because these are all things that I've cloned down over time. And then I know that I'm going to end up in the same place I was working before because I can't get jumped into the wrong place. And the last thing I want to show you about that is that especially this line should make you nervous, make me nervous, right? Like regular expressions are, you have two problems now. So it would be really great if I could test that I've gotten that correctly. Like maybe there's some edge cases I'm not thinking about. So I did that. So I import sys, I import import pytest. I do this one admittedly horrible looking thing because I need to be able to import conch stuff. And then I import conchgit, which is the name of that .xsh file, which is a conch script, but I can import it into a native Python file. And then I can use pytest and I can check to make sure that all of these different sorts of structures like HTTPS, maybe I'm using an SSH clone, maybe I forgot to put .git on the end of it. Maybe there's a number in either my org or my username. And am I checking to see if I have, was this like a full attempt at a clone or was it just like a jump to an org plus repo? And because it's Python, you can just run that. And this is how I know that my regular expression works for the things I care about, because I can test my dot files using pytest. Yeah. So that was like a wild whirlwind. That was what I have to show. There's a lot more to this, but it takes a long time to go through. And also I've forgotten like more than I've ever known about it. But I'm happy to take any questions. I hope you, oh, right, sorry. How do you end talks? Gil, good job. How to install this thing. It's fully well, no, it's not fully cross-platform. We had to drop support for Sun because of some stuff with Python. But Windows, Mac, Linux, BSD all work. The only strict dependency, except for on Windows, is Python 3. That's it. If you want some of the fancy tab completion, it helps if you have Prompt Toolkit. So we recommend that you install either from CondaForge or that you do conch full. You'll also get, I didn't even mention, like this kind of real-time syntax highlighting. That's coming from Pigments, so you need to have Pigments. Anyway, if you do conch full, you'll get it. And if you are on Ubuntu or Arch or Fedora or OS X, you can also install using your native, well, semi-native package managers. And we're at Conch. Come say hi. And you can find our website at con.sh for the rest of the documentation and a walkthrough of some more stuff, because there's a lot in there. So yeah, thanks.
All right, thank you.
Sorry if that was totally
Thank you
insane.
very much. No, it was great.
So speed lights, light speed, sorry.
That
someone
might
asked,
be the fastest live coded talk I've ever seen.
She's got to have nimble fingers and also a lot of auto completion. Somebody asked, how often do you release new features? What OS does this not work on? We've got a pretty decent release cadence. What are we at? We're at 0.10.1. I mean, we'll never release a 1.0 probably, but so we're, well, to be fair, we're 49 commits ahead of our last release. When was it? Yeah. At least once a month. New features come out pretty frequently. It works, everything works on Windows, OS X, and Linux and BSD. So it's totally cross-platform. There are some caveats around, like you can't run this in PowerShell, I don't think, for some reason. But if you have like a Windows terminal that can run Python, you can run this.
How does it correspond with Python distributions such as I know Anaconda, or I know you have if you have like virtual M's or anything like what's going on if you have like multiple Pythons going on?
Yeah, totally. So that's a really great question. So conch can't, sorry, libraries that I'm importing in conch here need to be in the site packages directory that conch itself is installed into. And that's just a limitation of the Python import system. We can't, in good conscience, like live reload you into a different site packages, maybe in a different version of Python, and expect things to work. But we have virtual lens support and Conda support. So actually I use Conda a lot. And we actually have, so I can tab complete my, my Conda environments, and those will just get activated. I did, let me just show you my path to show you that worked. Usually,
slower for a second. I asked you for a reason. When you did the Conda activate, you activated something that's installed in Anaconda or in some other mini-Conda environment, and now Conch is using that library, or is it like you're using a Python script? What's happening now?
Yeah, so if I activate SciPy, Conch is not actually in my path anymore because it lives in my base environment, but it's still running. If I do which Python, if I open Python, I'll get the Python that lives in this Conda environment. If I deactivate it, I'm back in my default environment, to my base. So Conch has to live in its own either in its own Python environment, and it's what Brew does. Brew tends to sandbox apps. So if you want to install something that Conch itself can natively import, then you want to make sure you install into the right environment. There's also a wrapper around activating virtual lens, but I don't remember how to use it, so I don't use virtual lens.
Thank you. This is good.
Yeah. Python. Jason, we do not currently have a hook for auto reloading of imports. Although if you you can, let's see, let me do this quickly. If you source something, it gets run directly. And if I change that, and I source it again, it will pull the new stuff. But if I were to have installed a library in here and I'd like patch requests, that's not going to reload. That's not going to reload the request library because that's Python's import system. And I know Python has a trick for hacking auto reload in, and we just haven't done it yet. Jenny asked, does this happen to have support for graphical output? It does, actually. I don't think I have it set up. So you're going to partially have to trust me, but we have contribs, those are contributions, MPL hooks and so matplotlib and matplotlib hooks, which will let you, print or show graphs in the terminal. If you're on some terminals, that'll look terrible. If you're on Kitty or iTerm, it looks pretty good, actually.
So what happens on Windows?
Very much this. It would look, you would, do, it would sort of, it's like a git bashy kind of I think actually I don't really use Windows, so I don't remember.
No.
But
So on Windows, it's like, will you do dir or do you ls still? Is it like?
That's a great question. We do give you an ls for people who are familiar with ls. If you do dir, what you actually get is the Python dir. So you either what you can do also in this case is and actually I'll kill this too really quick. So I showed you this where I overrode my own. Oops, nope. I overrode my own things. I can if I do let's see, $bracket, you can force a sub process evaluation. Say like ignore everything in Python. So you could do this for Windows. You can say like dir what's here, and that would. Oh, holy cow, that worked. I don't know what just happened because that shouldn't do that on Linux, but we apparently added something.
Well, okay, but the dir is like funny in Windows, yeah. Yeah,
no, that's the most prominent collision between Python and kind of built-in stuff on operating systems. So yeah, a lot of people will just add aliases or they'll use ls even though they're on Windows. So it's a little bit of muscle memory to overcome there. Or you do this. But
you support the basic command shells of the CMD basically, not the Unix command shells. Not.
Yes, yeah, no, you can run it in CMD. Yep.
Okay.
So if you don't mind, I'd like to think back to something you said towards the beginning of the talk, that conch is not quite POSIX compliant. Could you talk a little bit about where that might get somebody into a bit of unexpected trouble?
Start with explaining what POSIX is.
Woof. Start with that. All right. We'll go with the 10,000 foot view here. There are a set of standards that some people agreed on back in the 70s on sort of how all of these languages should work and sort of what commands should do things. So there's stuff around command redirection or how certain things get handled. And we don't follow all of those rules. So what that means is that unlike, for instance, if you have a script that you wrote in Bash, you can run it with Z shell and it will work. That guarantee is not made by us. So you will either have to run it directly by calling the bash -c and then passing it whatever you want to run, but you can't sort of seamlessly execute it from conch because we are going to parse the contents of your file differently and execute it slightly differently. What will probably happen is you just get an error because there'll be something in there that doesn't play nice with conch. So it's a bit of an investment of your time to switch over if you're really, really invested in how your shell is set up. But we sort of think it's worth it for a lot. If you like Python, it's worth it because it gives you Python to be able to configure all of these things. So that's sort of I guess that's the trade-off and the decision you have to make.
Yeah, that makes a lot of sense to me. I think when you had said that, I had assumed that there would be some like weirdness around, I don't know, like getting super user access or something on a particular system, but it doesn't sound like that would be the case.
No, yeah, that's totally fine. That also, sorry, I'm just not going to type my sudo password in right now, but but yeah, that works just fine.
Yeah, I think that's wise. So I really appreciated during the talk you showing us some innovative things that you had done. Just given that it's so easy to write these little scripts that you can say like, hey, I'm going to try to change my directory into this GitHub repo, and if I don't have it, it will automatically fetch it. Is there like a gallery or a collection somewhere where people can share like, oh, here is this cool thing I did using conch?
Yeah, what I would suggest for that, we should have a proper gallery, and we don't, honestly. But we do have a list of all of the contribs, which is sort of the way that people have tended to do this. So someone created one to automatically encrypt your history on disk and then decrypt it when you open up. There's a bunch of contribs that are kind of themes, so like the base16 theme. There's a Powerline clone if you like the way Powerline looks and you want your prompt to look that way. So I would say this is sort of the closest thing to a gallery of sort of fun stuff people have built. And some of these were written by us and by the maintainers, and others have just been written by users who wanted to have it easily integrated. Yeah.
Awesome. Well, thanks so much for answering the question, and thanks a lot for the talk. That was quite a whirlwind.
Yeah. So I have a quick question.
Yeah, please.
This is really cool because I love Python, and I generally like the idea of mixing shell stuff with Python. What was the motivation for this? It's a lot to wrap my head around, and I'm trying to think like, what can I do with it? Like, why does it exist?
That's
a
really great,
just a nerdy endeavor, which I would fully support.
Yes, it's a great question. It's partly a nerdy endeavor. The real answer though is when Anthony Skopas and Katie Huff wrote a book in 2015 or 2014 called Effective Computation in Physics. It's just effective computation. I mean, like O'Reilly added that to the title. And he had to write the Bash chapter and was struck by, and they were both software carpentry instructors, and was sort of struck by how there are all these like insane cryptic things you see in Bash, right? And be like, how do you teach somebody what this is going to do?
All that stuff the syntax is awkward.
Right. But also like, yeah, right. The syntax is super awkward, and it's really kind of, and it's hard for beginners to kind of pick up. But you're also then, you're maybe hurt by that, especially if you're like a new grad student in the computational sciences, that you don't have all the power of these tools available to you because you haven't spent the time or had the time to like learn this sort of arcane syntax or learn about how like awk and cut and grep and stuff work. So as part of software carpentry, you also learn Python. And so the idea was, well, what if we could just have Python be more or less integrated with it and make it easier for, everyone, but we were initially thinking of scientists to be able to kind of make better use of the file system and all of like, but not also lose all of like the really great tools that tend to be built into these things, including awk and cut and grep. These are all incredibly powerful things, but giving people like an easy way to get started. That was the idea anyway.
Have you used this in any sort of like commercial or production environment?
I have used it in a commercial environment. I use it at work. It's my default shell everywhere. I have deployed things to production environments using scripts I've written in it. But we don't have it deployed somewhere itself and running a tight event loop for serving something.
No. That's not what I mean. Like, say you're using infrastructure as code to deploy a simple web app, and you need to provision the server. Those scripts are a pain in the ass to write. If you're not like a Bash expert, which I'm not. I'm like a hacky command line guy. So I'm looking at this and I'm thinking, I have much more control over what I'm doing in Python than anything else. Mm-hmm. So do you feel like this is reliable enough at the state that it's in that you could reliably, as the right user, install conda, spin up a database, blah, 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 write a service, that kind of thing? Because it seems like it would be
absolutely.
Easy. I don't want to be tempted to think, oh, this solves all the problems, and find out I'm like badly wrong.
Yeah, I don't know if it solves all the problems, but yeah, if you have to, run a bunch of if you have a bunch of infrastructure as code that you need to spin up and you're using like the AWS CLI or something, or you need to create a SQLite database, or need to create a like Postgres, and do all those commands, like you can do that here. And then you can also just have, you can wrap those commands, get the return code, if it failed try again. I mean, you can, like, it's easy to write that logic in here because you can use sort of Pythonic thinking for it. I find actually the really fun stuff is when you realize what would be super helpful as a context manager. It's like I've written things to deal with the corporate proxy, and I have one command that like where I need to set the proxy, but then I don't want it set the rest of the time. So I could like mess with no proxy a lot, or I can have a context manager that I write that sets a bunch of environment variables, runs a command, and then unsets all of them.
That's really, yeah. Cool, I'm good. I can dork out all night. Jacob knows I can dork out all night.
Yeah. You'll have the chance.
Oh, and if Collier's still on, I know what I want to talk about. I want to go over that with you sometime.
Okay.
I'm here. Sweet. Yeah, I'll send you an email right after this.
Yep, cool.
Yeah. Any more questions, or are we moving towards stopping the recording?
All right, I guess no more questions.
Lauren?
Yeah. So yeah, thanks so much, Gil. That was awesome. So I'll start the recording now, but stick around.